I just want to run my code without thinking about it. I just want to fire my code up, give me a Alexa response back, and not care about the fact that it's an IP address and the technical domain. So serverless is all about run your code without even thinking about how that server got deployed, where it is, scalability, any of that. All that's gone with serverless. And really, you want to spend more time writing code instead of provisioning and getting all the servers set up. All right, so really briefly here, serverless tips. So this is kind of one of the fundamental things people ask. I hear about the serverless, when should I use this? And there's a couple of key times when I would recommend definitely use server. And there's a couple of more important things when you shouldn't even think about doing serverless. So real briefly, if you're doing a proof of concept, you don't need to care about all the scalability. You just want to get some code running. That's a perfect use case for serverless. If you've got a new application that's never been touched, no one's ever used it, another good use case for serverless. If you have to think about capacity planning, like I want to figure out how much server space do I need, stop thinking about that. Just go serverless. You don't have to care about how many CPUs, how much memory, all that's going to be taken care of for you by the provider. And then again, if you're worried about budgeting, you know, how much is it going to cost? Well, serverless, you're only paying for what you're using. You're not paying a fixed fee or anything. Every time you fire up your Azure function, you're going to get charged, you know, $0.50 or something. I think on the Azure functions, the first 1 million calls are free, so you can do all that without worrying about that. On the flip side, you know, when should you not use servers? Well, you know, if you're porting an AS400 app, probably not a good serverless campaign. That's probably more like a Docker or a dedicated server. If you're doing more of a long-running task, like if you're doing a batch job that has to run multiple minutes or hours, your serverless is probably not a good environment there. And this is probably the more web-centric. Like if you're running an e-commerce store or something like that, you need to depend on your server keeping transactions over time. You're probably going to want to keep that on the same server, which serverless doesn't really let you do really well. There's ways around that, but kind of a more advanced topic. So again, if you use older stuff, stay away from serverless, but anything new, anything that's sort of proof of concept, perfect candidate for serverless. All right, I think this is my last slide, and I'll kind of hand it over to Cecil after this. So this is sort of my list, but I think a lot of these kind of ring true. You want to run your code without thinking about servers. That's your serverless, number one reason to use it. If you're trying to lower your costs, you've got a data center and you're spending thousands of dollars every month, think about serverless, how that might help you. And this is a very new sort of development pattern is microservices. Anybody kind of use microservices today or starting to use them? It's the same service-oriented architecture that you've already known and used for the last 10 years. It's just breaking it further and further down so you have one function that does one thing, nothing else. So microservices is a fairly new idea, but fairly powerful in the serverless crowd. Anybody try to use Amazon Prime yesterday? So they kind of fell in the face if you saw what happened with the death puppy. The joke I was telling my wife when she asked me, like, what does this puppy mean? I said, that puppy means somebody's getting fired. Because the application was not scalable and robust, and I think a lot of the AWS infrastructure that Amazon uses is not the same that they give to their customers. So it's kind of a big fail for them. But in general, that's the reason to use serverless, is you want to be scalable and robust without having to do a lot of server code. And if you're a small team, serverless is perfect. I don't need to hire a server guy to do all my DevOps. I can do that myself. So if you're trying to save some money, trying to innovate faster, serverless is sort of the way I would start. Some famous use cases, Uber, Lyft, they all started with serverless. They didn't even bother getting a data center. And so this is how most newer teams start. They straight to serverless. Don't even bother getting a data center. If you get big enough later, you might have to have that conversation. But for the most part, that's it. So with that, I'll turn it over to Cecil. Thanks for your time, and keep about Centric.
All right, thank you, Cecil.
As you guys all know Dave, I know how many of you guys know me. I'm I help out here, but I wanted to officially present Cecil and all that. First of all, just wanted to let you guys know if you guys are interested in Arduinos and IoT at the end of the month on the 28th. Microsoft has sponsored an event up at Palm Beach Tech. So if you guys go to Boca.js, that's the last time I'll mention it, bocajs.org. You guys can come on over and you guys can see more information about it. Now, I've actually introduced Cecil many times. Because before he was just a speaker, as all of you guys have been once or twice. Now he is a cloud advocate at Microsoft. And you know, you introduced, then you said you said that it's going to be only Azure. I know Cecil. He's going to tell you the best solution for what you're going to have, regardless of whether it is Microsoft or not. He's telling me no, maybe he's shaking his head no. But there is no one better to present this than Mr. Cecil, who's the best speaker I know, and the reason why I went into speaking is the gentleman. Ladies and gentlemen, Cecil Phillip.
No pressure at all. No pressure. All right, thank you all for coming. Appreciate it. So kind of what Damien said, my name is Cecil Phillip. I'm a cloud developer advocate at Microsoft. So what me and my team do, essentially we go around to try and make sure developers have a good experience building an application in the cloud. Right. So my team, very specifically, we do a lot of like workshops. We write a lot of documentation, samples, things of that nature. Right. So kind of just to give you an example of some of the things that we've been doing thus far. So recently we released this thing, so Azure Functions recipes. So this is on our box right now. This is just a set of tips and tricks and best practices around using Azure Functions. So we also have very detailed documentation, but you know, sometimes you're just working on something you just want a really quick answer, like a very short sentence of code, just try it and run. So we started with this, and it's been going really well so far. One of the things I love about this particular project is that it's actually supported a lot by the community. So you have a lot of people that are contributing samples from different languages, from F#, C#, different types of use cases and stuff like that. So if you ever decided that you wanted to contribute a sample, like we'll very much appreciate it. Another thing that we just released last week. So we just released this book, and we as our team. My name's not on the cover, so I'm a little bitter about that, but that's okay. So serverless apps, architecture patterns, and implementation. So again, this is a free ebook. Free as in like you don't have to give me your email address or anything like that. Like, you honestly just go and read it, and that's it, right? Nothing special has to happen. I have links to all of these things that are in the slides too, so you'll be able to download these and get them trained. Alright, so let's kind of talk about service. Now, can you guys hear me in the back? I know it's a little bit noisy. Are we good? Okay. So I know Chris talked about it a little bit, but I kind of just want to, I like to start from the beginning a little bit and kind of frame the picture and kind of tell the story, if you guys don't mind. You want to do that? Yeah? Alright. So I remember a couple of years ago, well, maybe not a couple of years ago, when I first started programming, right? Like we used to, have physical machines inside of our infrastructure. So I used to work at university. I used to work at Northern Southeastern University actually, and we had Windows 2000 servers, SQL Server 2005, and it was honestly copy pasting to a folder, right? And that's how we got work done when we think about it. Right? Over time that became a little problematic because it was like, well, what happens if you need another server, right? Or what happens when we need to scale? Right? Like who's managing the updates and things like that? Not to talk about their secrets too many, but like a lot of the apps we ran were literally one server. So if that server needed maintenance, like a lot of our internal things went down, right? So that became very difficult to manage, very frustrating to manage. So one of the things that the cloud gave us was this thing called IaaS, called infrastructure as a service. So that means that, okay, I don't need to manage my infrastructure anymore. I can have somebody else do that for me. Right, this is pretty much like a hosting model, right? So I can come to you and I can say, hey, I want this virtual machine, I want so much memory, I want so much RAM, I want Windows, Linux, whatever the case is. And it's going to be up to that provider to manage that for me, whether it's GCP or Google or Rackspace or whoever it is that you decide to use. And that was great, but you still have to be thinking about the operating system. You still have to worry about how much memory do I need, and I can still have to manage my updates and things like that. So So then we move forward a little bit, and now we have this thing called PaaS, right? I'm sure you guys have heard of PaaS before, right? Platform as a service. So with platform as a service, what we get is, okay, well, I don't need to worry about the operating system so much, and I don't need to worry about the scaling so much, but essentially I can kind of just publish my application, I can publish my code somewhere, and then I can just let it run, right? Now, one of the things that we don't get with PaaS is that, I still need to think about, well, how does this scale, right? Like, how does this move up when I have heavy loads? Like, the example I like to use is, let's say it's Christmas, and, it's a heavy shopping season, and maybe you're running an e-commerce website or something like that. Like, how do I manage that scale of, hey, I'm gonna have a ton of users that are gonna come in, and then, in January, like, they're all gonna go away, right? I'm not gonna have that consistent traffic. A buddy of mine, he used to run an e-commerce site. He told me, what he used to do, he has to go to the store, he bought racks and servers, and he put them in his rack. And then, when the customers were gone, he had to keep them because he bought them, right? Like, so now you have to keep that infrastructure, you have to maintain it, you have to keep using it, right? And so this is one of the things that we get from serverless now. We don't have to worry about some of these types of concerns. Now, the word serverless for a lot of people is like, yeah, right, like there's a server somewhere, like, where did this thing really go? So the way I like to tell people about it is, imagine like your wireless router, right? Like your wireless router has wires, right? It's plugged into something, like that information is coming from somewhere, but you just don't think about it. From the perspective of the person that's consuming that information, that's consuming that service, you don't think about it, right? Like your tablets, your MacBook, whatever it is that you're using, you just kind of like turn on your Wi-Fi and you connect it. So it's the same thing with serverless, right? Like you don't really think about the infrastructure. The infrastructure is there, and somebody's managing it and taking care of it for you, but you just don't have to worry about it. So now that kind of gives us a new paradigm for how we develop our apps, how we deploy our apps, and how we scale our apps. So when we think about like what are some of the core tenets of this, right? We think about the ability that serverless is a very event-driven type model, right? And I'm going to show you exactly how some of that works when we look into the code. But essentially, if you have anything that's very much, like you want some piece of code to run when a new user is created or a new file is uploaded or anything like that, like serverless is a good option for that. Another thing too that I like about serverless is that, again, you don't really, for most providers, like you only pay for use. Right? So think about it like electricity, right? Like if you don't use electricity, well, and maybe not in Florida anyway, but if you don't use electricity, like you really don't have a huge bill. Like you're not going to pay for things that you don't use, right? But if I had a virtual machine, if I had a PaaS server somewhere, like you're going to get that consistent bill every month. You're always going to pay for it, whether you're using like 10% of it or whether you're using 100% of it. So again, one of the great things about serverless is that it kind of helps keep your bill down, which is great too if you're a new company, you're starting up, you're really trying to watch your costs and stuff. Now, from a developer perspective, like we want to talk a little bit about what are some of the benefits for your company, your development team. So again, like as a developer, again, I used to remember. I'm trying not to use any names to get anybody in trouble. I remember a while ago, I wanted to deploy this application, and I was like, hey, could I have a VM that I could put this on, like this a dev server, nothing beefy or anything like that. And that took me like 2 weeks to get that server. Now, if you think about the rate at which we develop software, we publish, and we deliver software, 2 weeks to wait for a dev machine is not acceptable. Like that's not something that we can, we can't do that, right? Luckily, obviously, the cloud has made this thing a lot more easy for us to deal with. But now, even so with serverless, again, I don't need to worry about what I'm deploying to. Right? Like I don't really need to think about so much about the server or backups and things like that. Like I just give me the endpoint and I'll send the code over there and somebody will run it for me. So that obviously changes the way that we deploy our software. It also kind of takes away the distractions of what that process is. Right? Like I can completely focus on just whatever it is that my company does. So again, like if I use the example of insurance, if you're an insurance company and you write insurance software, I'm sure your company doesn't want to think about, the CPU utilization and the RAM and things like that. Like you want to write insurance software, you want to solve insurance problems, right? Like you're not an infrastructure company, so you're not in the business of doing these types of things. And so that's one of the things that serverless kind of helps you deal with. Now, when we talk about Azure specifically, like we have a few different components that kind kind of make up our serverless offering. Now, when a lot of people think about serverless today, on a very, you know, when you listen to a lot of the marketing folks talking about it, like what they're actually talking about is serverless compute, right? So if you hear about AWS Lambda or, you know, Google has Google functions, we have Azure functions. That's specifically serverless compute. So that's saying, hey, I'm going to give you some code and you're going to run it for me, right? And you know, whenever it's done, you give me the result back, right? Like you're going to do some processing. We also have some other tenants that come into serverless as well, right? So one thing we have is this thing called Event Grid. So Event Grid again is just like our event routing service. It's one of the things. It's one of the things that kind of triggers off like how our functions run. And again, that happens in a very serverless way because all you say is like turn on the service, and you just use it, right? Like again, I'm not thinking about scale or anything like that. And you pay for it for use. Another thing that we have is logic apps. Have any of you heard about logic apps before? Some of you? Right. So like logic apps is almost like a designer. It's a designer-based interface where I can go in and I can drag some things around, I can click on various services, and I can plug them together in a very visual way. Right? So there's no code involved, well, there's very little code involved, and if you have different services, like you can kind of plug them together. The benefit with logic apps is that it has a lot of great integration with third-party services. So again, if I need to plug into SAP, or I need to plug into SendGrid, or Twilio, or anything like that, like all we're talking about is like clicking on connectors, putting in your credentials, and clicking sign in, right? And we have various actions that kind of help put those things together. So again, that's just something that you don't have to worry about. So as the request for that come in, again, like the system scales itself, right? Like you don't come in and say, I want a new logic app on a Windows server with 10 gigs of RAM and so on and so forth. You just kind of design the application until it's run, right? And then everything else is just like a pay-per-use type of stuff. So let's specifically talk about Azure Functions. So again, like I told you before, like Azure Functions is essentially our service compute offerings. And so the way it kind of runs is that first we start off with events, right? So what exactly starts my function from running, right? Like if we deploy an application today, like you're going to have you know, a program.cs or a program.main, or like something's going to start your program running. And you're going to have buttons and things of that nature that kick off operations. So like in a serverless world, there's no button, right? Like it's just on a machine somewhere. So we need events to let us know, hey, it's time for this thing to start running. So some of the events that we support today is, you know, we have timers, you know, we support HTTP triggers. You might want a function to run maybe if I might upload an image to a folder somewhere. Or you might want an event to run if I add something to my Cosmos DB instance or something like that, right? Again, events, again, is a very first-class citizen that say, hey, whenever this thing happens, I want you to start running and I want you to start processing my application. And then next, obviously, we have the code, right? So the code aspect of it, today we support, you know, C#, F#, Node.js, Java. We have Python support coming if you're going to use Python. What else do we have coming? Yeah, we have Node there as well. We have a few different languages that are coming. Like, so again, this is not just a .NET thing, it's not just a C# thing or Visual Studio thing. You know, depending whatever language you want to use, whatever framework and stuff like that that you're comfortable with, you know, we probably have a solution that's going to make it able for you to run inside of the service function. Right. So we have events, we have code, and then obviously we have the output, right? Like our function is going to do something, and then those results need to go somewhere, right? So like, what are the outputs? And so one of the cool things we have are this concept of bindings. So imagine I'm going to write my serverless function, and I want it to go out to, I don't know, maybe I want to return an HTTP response, or I want it to go inside of a table, or I want to create a queue or something of that nature. We have these powerful things called bindings that essentially, like, they kind of add another layer of abstraction. So like, you don't necessarily have to work with that API directly. You can kind of just return an object or a string or something like that, and it'll just automatically go where it's supposed to go. Which kind of sounds like black magic when you first see it, but it's actually really cool. So here's our example of some of our triggers and bindings. So again, I spoke about, we have timers that, you know, run in a physical interval, we have HTTP triggers, event grids, queues, and things like that nature. So let's take a look and see what a timer trigger looks like from a code perspective. So at the top left, can you guys see the code in the back? I just want to make sure that's visible for you. Yeah? Okay. So when we take a look at the function, so again, this is a C# example. I'm going to have an annotation that says, hey, this is a function. This is my Azure function. And then on that first line, you'll see something I have called timer trigger. So again, that's an annotation that I'm putting against that variable that's letting me know, okay, this is the interval that I'm going to have this function running. Right? Like that's my trigger. Like that's what's going to start my function from executing. Right? Then obviously I have a logger. So obviously I'm going to use my log to get some telemetry, some metadata, and save that information. And then the last thing I have there is my output byte. So I'm going to say after this function is run, I want to have a variable called queueMessage. And so when I assign that whatever value to queueMessage, it's going to go ahead and put a message on the queue. Right? Now one of the great things you see here is that I have no code here specifically in terms of connecting to the queue, creating the queue, or anything of that. All that is abstracted for you. You're working with regular objects and strings if you want to. Obviously, if you wanted to go a little bit more deep now and you wanted to get more detailed in the API and use them, you totally can. But again, we just make it super easy for you to kind of get started with, started use everything. Any questions about that? No? You guys want to see a demo?
Sure. Yeah.
You guys are like still dealing with that food, right? Like, is that what's going on? Alright, let's take a look at a demo really quickly. So what I'm going to do, I'm just going to show really quickly how we can get started with Azure Functions. I'm going to pop open my Visual Studio, and then what I'll do too is I'll go inside of my Azure portal. Okay, I don't mean to do this multi-factor there. Alright, let's change, I think I'm in the wrong directory. Microsoft. So, here inside of the Azure portal, as soon as it's loads, so this is where you kind of come in and to create your Azure function. So, what I'm going to do is I'm going to go into my resource group. And I have a resource group called Serverless Workflows. And inside of that, I have a function app that I created. Right? And essentially all I did was I went to create a new function app. And that's essentially all that's inside of there. I've done nothing special with it. And so when it's fishing, so this is what your default function experience kind of looks like. Now, what I want to do is I want to create a function inside here. So let's do this. I'm going to call this, let's see what I'm going to do. I'm going to call this, let's say, where's my function here? Oh, you know what? I can't do that. I was supposed to delete that. Let's create a new one. I'm going to create a new one from scratch. Function, app. I'm going to create a new function app. And let's just call this FLADotNet. Right. I'm going to put this in my resource group. I'm going to put this in my workflows group. I'm going to leave all this stuff as default. This is not important, really. I'll turn it off. I'm going to hit create. Now, all this is going to do is it's going to go ahead and it's going to provision an Azure Function app for me. And it shouldn't take too long. It should take, just a second or so. And what I want to do is show you how you can create an Azure Function inside of the portal in a completely web-based way. And I also want to show you how you can create it inside of Visual Studio. So I'm just going to give this a second run. This should be done any minute now. And then we're going to go ahead and create this function. So while this was running, any questions or anything anybody want to ask before I keep going? Yes, sir?
Some of that configuration, can you change that later? Like the inside?
Some of it you can, some of it you can't. Right? So if you notice when I started it, like you had an option of using Docker containers or not, you can't go back and change it later. Right? You probably have to create another function and copy them over. But no, some things you can, some things you can't change. Any other questions? Yes, sir?
So one of your first slides you had,
I'm sorry, what did you say?
one of your first slides you had,
So one of your first slides, you had a Unity recipe. So if you could, like, at some point, your president, not now, but at some point, go over that.
Oh, okay, sure. I know
Or if I don't see it on this screen, I saw on your slide earlier.
Sure, I'll digress a second and show you exactly what that was. So remember I told you my team, we have this thing called Azure Functions Recipes, and it's this website if you go and get these little quick snippets. So on that website, and excuse the resolution, I'll actually Maybe I'll make this smaller. Right, there we go.
Is this where your book is also?
The book is also on this doc site as well, yeah. So here you notice we have Azure Functions recipes here. The unique thing here is something different. So like this area here is essentially where all our team goes and we put samples and docs and things that you could use. So specifically for Azure Functions, we have a functions recipe section here. But also notice we have things for game development and this is some machine learning demos and things like that we have here as well. So again, everything here is totally free. You can go and read it and download it and try it if you want. This one? Sure. Yeah, this is some SDK work, some Azure-based SDKs. We're working with Unity that we're working on. So you can come in here and see all of that work. Yes, sir. Question?
Since you mentioned queue, do you have like inter-process communication for synchronizing?
Can you do inter-process
communication, like flags and semaphores and queue messages?
Sure. So because of the way that function runs, so functions are made to run in very much of a distributed parallel way. So in terms of communicating between them, like you don't need to worry about thread locks and things of that nature in terms of talking between different functions. But you can use so a common pattern is to use queues and queues or tables or things of that nature.
You can pass messages between two.
So you can pass messages between the two. But when I show you durable functions, I'll show you a little bit of a cleaner way that you can do that. And we're going to see that closer to the end. Sorry, so my Azure function is created. I'm going to click go to resource. So again, this is totally empty. There's no functions in here right now. Now I'm going to hit this plus button. And what you'll see here is that I have my quick start section, and I can kind of come in here and I can say, well, what type of function do I want to create? Right? So I want to create a webhook or a timer or data processing situation, whatever. And notice here at the bottom as well, I can pick different programming languages. Now, if I wanted to get more of a detailed view of the different types of functions that I want to create, I can click down here where it says create your own custom function. I'll click on that. And so what this will do is it'll take us to the area that has all of the various templates as soon as this loads. But now you see I can have C#, F#, JavaScript, there's Q triggers, there's service bus triggers, Cosmos DB, so on and so forth. If I click on this experimental language support thing, notice all of a sudden there's more languages that kind of pop up. Now the reason for that is the languages that show when it turned off are the ones that are officially supported. So that means that they're production ready, that means that you can call support on the phone and they'll help you work through your problems. These other ones are use at your own risk type thing. So if you use it and you put it in production and something breaks, then we can't help you because they're experimental. So what I'm going to do is I'm going to create a HTTP trigger. So I'm going to do this using C#. I'll just call this demo trigger. I'll put this as anonymous. So what authorization level is, this essentially is just a way for you to give your function API keys for pretty much essentially is what it is. I'm just going to leave this anonymous for now because we're not going to talk about security too much today. Alright, so now what you see here now is that I have a code editing experience for my serverless function, right? So if I wanted to, I could just come inside of the cloud, right? Or I could come inside of my web browser and I could write some code and I could just hit the run button. And now Azure and the infrastructure behind it is just going to manage that for me. So one of the ways that we can test this, I can hit this little test tab here on the right side. And notice I can add query strings, or I can add headers and things of that nature. And if we scroll down a little further, basically, just because of my resolution, I can hit this run button, right? And notice I'll get my response back here. Another thing I want you to see is on the left side, let me move this around a little bit. On the left side, notice we have this little log section. So as your function is running, because I have those log statements in it, those logs are going to automatically get pumped inside of this function. Right, so that's one thing that you can kind of come in here and check out. So that's essentially how you run a function, in the browser, or create it in the browser. Now, for me personally, I'm very much of a Visual Studio guy. I like the sharper, I like debugging, I like being able to set breakpoints and do some of those types of things. And you can't do that in the browser. The browser is more of hey, I wouldn't want to write something really quickly and paste it and run it. I'm sorry. It's more of I just want to do something really quickly. If I want to use like some of the tools I'm more familiar with, I can use Visual Studio Code. If you're a Java person, like there's also IntelliJ IDEA support too, if you want to do that. So I'm going to go into Visual Studio. I'm just going to create a new function. I'm going to show you how this works really quick. So I want to click on Cloud, and then notice I have this thing that says Azure Functions. I'll just call this timer function demo. I'm going to say OK, and then this should scaffold out my function for me. I'm going to select timer, and yeah, I'm just going to leave that as OK. Right? And so now what this is going to do is it's going to go ahead and generate my project for me. You know, my CS prod is going to pull in the NuGet packages. It's going to generate whatever code I need to kind of just get started. Right. So again, very quickly, like here's my Azure function. Now, this particular function is different. The last one we saw was triggered by an HTTP request or return an HTTP response. This one is purely run based on the timer. So how many of you are familiar with cron, like cron notation for timers? Right, so like what this does is that, you know, inside of my timer trigger, I could essentially give it like some cron notation. And then based on that, that tells it the interval into which it wants to run my trigger. So right now this is set up to run every 5 minutes. That's what this /5 does. Now, we're not going to wait 5 minutes, because that's a long time. So let's do it, how about every 5 seconds? Right? So now I'm going to have this function. I want to run every 5 seconds. Now, I wanted to do something. It's not really doing anything right now. So what I wanted to do is I wanted to call my function that I wrote that's running in the cloud now. Right? So essentially what I want to show you is that I'm going to be working with 2 different functions, one in the cloud, one on my machine, and then I want to be able to talk to both of them. So let's do this. So I'm going to come back to my function. So this is my HTTP function. Notice at the top here that we have this thing called get function URL. So when I click on that, what that'll give me is the endpoint that I can send requests to for this function. Okay? So I'm going to click on that. I'm going to copy it. And now when I go back into Visual Studio, what I'm going to do is I'm going to issue I'm going to create an HTTP client. So I'm going to say var client equal to new HTTP client. Right, we're going to bring in the namespace for that. Right, and now what I want to do is I want to say client.get as string async. So I want to get my result back as a string. I'm going to paste that in there. Oops. Okay. And then so this is async. This is an async call. So I want to make sure that I await it. So response is equal to await. Okay. So one of the things you'll notice now is that I can use async await inside of my Azure functions, right? So again, it's just like a regular C# function. Nothing special needs to happen. So because I put await here, that means that I need to make this an async function. So I'm just going to say async task, right? Oh, spell that right. Async task. Obviously, I need to make sure I bring in the namespace for that, and then now I can start, you know, continue writing this async await type stuff. Now, what I'm going to do is I'm just going to, so now I got this response back, I'm just going to print it out. Right? I'm not going to do anything special with it. So what I'll do is I'll say log.information or log.info, and then I'll use, let's do, here is what we got back, right? So let's do this. I'll put the, I'll use this fancy notation that we have, I'll put response, right? And then that'll be inside of it, right? So hopefully what should happen is that every 5 seconds when I start to run this function, it's just going to hit that endpoint, and as it's hitting the endpoint, it'll just say whatever the response is. So I'm going to go ahead and run this really quick. So one of the cool things that you'll see is that I'm going to have a little black and white terminal that's going to pop up. Now this is the Azure Functions runtime on my machine. Right? It's not a simulator or emulator or whatever the case is. Like this is actually running the same runtime that's in the cloud, but it's running it on my machine. Obviously in a very much scaled out type way. Right? So one of the things you can get from that is that, you know, when it runs, I know with confidence when I deploy it, it's going to be the same type of thing. So when you're seeing here now, I'm getting a lot of red here. Like there's obviously a problem, like some errors that are going on here. And so you'll notice it says bad request, function 1, something. Now, so let's go and take a look back at our function and see what's going on. So what you'll notice is that this function expects a parameter of name, and I never gave it to it, right? So again, locally in my function, you know those errors are coming back. You got a question?
You said it's supposed to run locally rather than
I'm sorry.
How'd you set it to run locally rather than on the cloud?
Because I haven't deployed it yet. I created it on my machine. Right? I said it was like file new project from Visual Studio. I created the function on my machine. What we did the first time is that I created it in the web browser in Azure. Right? So I have one function running in Azure, and this one is running on my machine. Right? And I'll show you how we can deploy it in a second. But we haven't deployed the function yet. But the functions are talking together, right? Because one's in the cloud and has a public URL, so I can access it. And this timer is just like spinning off locally right here. So this is expecting a name parameter. I didn't give it to it. So I need to just add a query string. I'm going to say name equal to, let's say, FLADotNet, right? Let's do that. I run it, and now let's see if those red things go away. So again, doing the same thing like I was doing before. Like it's booting up my function. It's loading whatever plugins and so on and so forth it needs. And I'm hoping what will happen is that, so notice here we're getting our message back that says, it's going. But those are referring to hello FLADotNet, right? So again, I have a local function that's talking to a function that's in the cloud, and we can have like a little bit of communication going back and forth. Any questions about that? Really quick? No? Okay. So now to address your question, so now I have this function here. How can I deploy it to the cloud? Right? Now, one of the things about an Azure function is it's very similar to deploying like an ASP.NET Core app or ASP.NET app in general, right? Essentially what you're going to do is you're going to compile it, you're going to get some DLLs, and then you're going to copy it over to the server that it's running. The thing to note about Azure functions is that essentially it's running on top of app service. Are you all familiar with Azure App Service? So Azure App Service is our platform as a service offering, right? It's where you create web apps, mobile apps, API apps, anything very web-based, like you probably want to run it inside of it. Now, what I'm going to do, I'm just going to right-click publish. For the DevOps people here, don't get mad at me because I'm right-click publishing. Like if you have CI/CD and TFS and all that stuff, that's great. We don't have that much of time, so we're just going to do this really quickly. So I know that I already have a function created in Azure, right? So because of that, I'm going to click select existing. I'm going to hit publish. Now what it's going to do is going to look at my subscription. It's going to pull down those different, those different apps that I have. So I can select which one I want to run it. So I want to put this in, so this is a resource group, service workflows. Can I click this? Is it simple? Alright, it's still thinking about something. But essentially whenever it's done loading, I should be able to click it, and then I can select the specific one I want to use. This is stuck. Let's try this again. Alright, that's better. Great. So we have this FLADotNet one. Sorry, this is the function that we created like. Alright, so I'm going to let that spin for a little bit. So essentially, again, when we think about functions, right, like we have a very different way of building and deploying our apps. Notice that at no point in time did I say, hey, I need 10 gigs of RAM. At no point did I say I need this CPU or GPU or anything of that nature. I was just like, hey, create this function after me. I'm just going to publish code. And so one of the good things about that, again, is as your application scales, or as your requests and your traffic increases, like it'll just increase for you automatically, and then you'll just get billed per use. One of the good things to know about Azure Functions, you get 1 million executions for free every month. So, I mean, for most small to medium-sized businesses, they're probably not doing 1 million executions, so it's almost like a free service. Free from the perspective of the compute. Obviously if you're using databases and other things, like you have to pay for those, but if you're just talking about the raw compute, you get 1 million executions for free, and it's something like 400 gigabytes per second, which is a weird calculation of how much memory you could consume per second. Okay. Alright, so this is finished. I'm going to hit publish, and now this should, again, it's going to build, it's going to bundle our app up, and it's going to send it over to the cloud. And hopefully that shouldn't take as long as it did the last time. Alright, that looks like it's done. If I look at my output, to succeed it, I'm going to go back over here, and then if I refresh this, there's a refresh button somewhere. So if I refresh this, so notice it says function 1, right? So where did function 1 come from? Well, that was the name of our function, right? You notice it says function 1, right? So that's the name we gave. So now, if I kick this off, if I go to function 1 and I go ahead and kick it off, right? I'm just going to go ahead and hit run, and I'll just kind of leave it. So notice that's jumping. Notice every 5 seconds or so, like that logging window is going to pop up, and my function is just running, right? And essentially, I'm just going to let it do what it needs to do. Question? Is there any way to? In terms of like version control for functions, you mean?
As ops, like from an ops point of view, is there any way for me to see what are the differences between one deployed function or another, other than looking at the source code?
Oh, okay. So I would tell you, so if you create your function in the web interface, so that's like you're giving away a lot of things. Like there's a lot of stuff you don't get. Like I showed, like there's no debuggability, right? Like you can't really test it and then just running it. But then also feel like there's no source control, right? There's just I copied some code into this thing and hit the run button and now it's running. So that's probably not what you want to do in terms of like a day-to-day basis, how you build like larger scale applications. Probably what you do want to do is probably use, again, Visual Studio. We have integration with Git, which is one of the things that we like to demo. So I can actually have an Azure function living in GitHub or whatever Git repository that you use. And then that's essentially what we'd use for our continuous delivery story, right? So like whatever branch you put it in, it's like this is like the live branch or the master branch, whatever style you like to use. And so when you publish it there, like it'll automatically compile, build, and then publish your function. So one of the things I want you to see here is that so that first function I created, you notice how I can kind of come in and I can type and I can I can edit the function in the browser. Notice now that I published from Visual Studio that this is all grayed out. It's in read-only mode, right? It's read-only now because the source of truth is no longer in the browser, right? Like it came from somewhere else. So now it's saying, hey, I can't just come in and change stuff in the browser, right? Like somebody else kind of has to trigger that. So those are some of the things that we kind of have to make sure that that type of workflow is a little bit more consistent as you build more functions. Question?
I noticed you deployed it to runs in the context of an app service, right? So an app service typically has a plan associated with it, right? How does that work, an app service plan in relation to the actual deployment of these serverless functions in that app service? Because you typically pick a tier of an app service plan.
Sure, so that's a really good question. So what I did here, so I came here to this is my main function area. Again, so this is the function I created, I just picked it at the top. Now, app service plan, what you're talking about. So for everybody else that doesn't know what an app service plan is, essentially, it's almost like, so when you're using Azure App Service, I can say, again, I can pick the size of machines that I'm going to run my stuff on, right? So when you run an app service for functions, you have two options. Let's say you have an app service existing already, and you're not utilizing it a tremendous amount. You can attach your function to it, and essentially you'll just use up like that free, those free compute cycles. You know what I mean? So that's one option to have. What I did here was I'm using the consumption model. So the consumption model is pretty much, I'm just gonna eat compute, right? Until there's no more compute, essentially. So it's not attached to any plan per se. It's more so, hey, I'm just gonna deploy out into the cloud, and then as I need to scale up, I'll scale up, and then as I need to scale up, I'll scale down. The difference with that, attaching it to an existing app service plan, is that obviously your app service plan that exists has a limit. Right? So once you hit that limit, then you're going to start seeing performance issues and throttling issues and things of that nature. So that would be the difference. So you pick one or the other. Most of the time, you're probably going to want to have a consumption plan. Again, unless you have like an existing app service plan that you can just, you can just reduce. Yes, sir?
So if you own a consumption plan, for example, right?
So is there a cap in terms of scaling? Let's say your client is DDoSing you. So where is the cap? Or is it going to just eat all my budget?
So if they're DDoSing, sure. So one of the things that we can do, so in some of our configuration settings, so you can set up things like the throttling rates or the polling intervals and things of that nature. So like again, let's say you have a queue, like you just killed tons of queues, right? Like the online function is scaling ridiculously. Like you might want to tune down the dequeuing, right, of your machine. So those are settings that we can put inside of the machine to kind of slow things down a little bit if it's going too fast. From an HTTP perspective, one of the things that we like to do is we like to tell people to put like API management in front of it or proxy in front of it. So now that kind of, there's a layer of authentication there, and then there's also a layer of, you can put some middleware there to help throttle that stuff down. You know what I mean? So there's things that you can add to the function that kind of help deal with that type of scenario. Does that make sense? You have a question? Not sure? No, the guy next to you. All right.
Still, in this case, in case of DDoS, it's going to use all my money for just that amount of requests, and my read client's not going to get my function executed. How it's going to work? I mean, in this case, what I'm going to do. For example, I have 1 million free requests, and it's going to be like DDoS for 2 million requests. And my clients would not see the function at all, or what's going to happen in this case?
Sure, so then you probably want, again, you want to have some layer of authentication in front of it. So one of the things I kind of showed you, what I kind of didn't really show you. So if I come into, which one is the HTTP one? This demo trigger, right? And I think it's inside of manage. All right, so remember I talked about the keys, like the API keys, and I just have this as anonymous right now, but you probably don't want to have it as anonymous. So what anonymous means that anybody can call my function from anywhere in the world and they can just hit it. One of the things you probably want to do, specifically for an HTTP trigger, is you probably want to create a function key, right? And then you can create multiple keys or different keys, whatever the case is. So that before it even runs your function, like there's some code that's in front of there that's going to say, hey, you don't have this key, and I'm not going to let you call it. You know what I mean? So that's probably one of the things you want to do. If you're doing anything that needs like a user context, so like you could back with Azure Active Directory if you need like a user. It's like a function key is just a key, right? It's just like a yes or no. Can you get in or not type thing. If you want a user, then you want to back it with like Active Directory or like some user context. And again, it's really just a matter of like just turn on Active Directory, and then have that user token get sent back and forth, like using JWT tokens or something like that. So like those things can help mitigate like those types of things. Because again, more than likely, you're probably not just going to open your function and be like, hey, free world, come on, call my stuff. You probably want to put something in front of that to kind of manage some of those types of things.
You know, Cecil, that even if you do, the fact that it's functions means that they can't DDoS you. Okay, you're paying for 2 million requests, but that 2 million at first for that one client that's going to pay you $1 million gets through.
Right, so there you go. So let's, what time is it? Alright, so let's go back to the slides really quick. So let's talk really quickly about use cases. Like, what are the scenarios that I want to use serverless? Or what are the scenarios that Azure Functions kind of make sense for me? And so here are some of the things that we've at least seen our clients do. I know when functions first came out, like chatbots were a big thing. Everybody was building a chatbot. You know what I mean? But I don't want to have to stand up a server every time I build a chatbot. Right? Like, so Azure Functions has been really good for those types of scenarios. If you're doing anything with like Spark and Kafka and any type of like real-time data ingestion, you know what I mean? Like our event-driven model is really good for those types of things. Background tasks, like long-running background tasks. We actually have some. I'll show you some of that in a second. Stream processing. Actually, that sample that I just wrote just now. So that's actually very much of a scaled-down real-world scenario for a lot of our customers. Right? Like I'll have some web property somewhere, and I'll have a timer somewhere, right? And my timer is essentially doing like a ping, right? It's like a keep alive, right? Like I'm not going to put it in 5 seconds, but like I'll have something keeping alive my server. It's pinging my cache, or whatever the case is. But you set your interval, and then you just know that it's pinging it. If if any of you have deployed the FLADotNet applications, you know after a certain point, like, you know, the application pool gets drained, and the application has to rebuild itself, and there's time that happens there. You know, so one of the things that a lot of folks do is that they just have a thing that just keeps pinging the server. And again, I mean, you have 1 million free executions, like you can afford to ping the server like a couple of times a day. And it's not going to cost you, you're never going to get 1 million. So that's never going to be it. Another thing that we talk about too is doing like lift and shift or like slow migration into the cloud. So a lot of folks, you know, we have like this hybrid type scenario where I have some applications that are on-premise or somewhere else, and I want to slowly start putting stuff in the cloud, right? But you don't necessarily have to pick up your whole app and move it over. You could say, okay, well, I'm going to have this one API endpoint, and I'm going to put it in Azure Functions. Or I'm going to have this one little thing over here, and I'm going to put that in Azure Functions. And essentially, kind of like what you saw what I did just now, right? Like I'm calling a function in the cloud from my machine. It's no different from you doing that in your own infrastructure. Obviously, again, putting in the proper security context and things of that nature. But I mean, that's very much a very common use case. Now, let's take it up a little bit. Now, functions are great by themselves in terms of creating siloed bits of functionality. Right? Like I have a function and it does this thing and it does it really well. Right? Like we think about like the Microsoft, the microservice analogy a lot. People talk about. Question?
Quick question in terms of coding. The function itself is just one static function, or can I add some references like DLLs, whatever? For example, if I have outside monitoring like New Relic or Splunk or whatever.
No, sure, you totally did that. So the function's runtime itself is essentially a NuGet package, right? So you can add more NuGet packages if you like. So I also went to the dependencies here a little bit, and you know, when I scroll over, right, it's NuGet, you know, Azure Function. If you open this, this has like its own set of dependencies and whatnot. So if you wanted to add, I don't know, maybe you had like a fake data generator or something to use, or again, you wanted to bring in like MSAL, the Microsoft Authentication Library or something like that. Application Insights has an SDK, like you can bring those in.
So you can deploy it as a product?
Essentially, it's a product. Again, so when it builds, when we build it locally on your machine, when it builds, it just creates a set of DLLs. Again, very similar to how ASP.NET runs today. Yeah. Sure. So again, so this is a regular project. It's a CS project, right? So if I right click on this, like this is the project file, right? It's an MS build file, just like any other any other .NET application, right? Build, it creates artifacts, and then you copy those artifacts and put them in the cloud. And then the runtime is intelligent to know, like this is where the start point is. You know what I mean? Like every application has a start, right? Like program CS or something like that. Yes. Yeah, pretty much. Any other questions? Yes, sir.
Would you put an entire application in there, or let's say you have a web API, put the routing within the function instance, or would you break out the resources in your API, create one function per resource? You know, an API, let's say you have you're trying to do a REST API. You know, you've broken it down to my personal resource, my customer resource, my other resource. Would you then say, okay, I'm going to create a function with the order resource, a function for my customer resource, or would you just take your entire ASP.NET Core application and put the startup in that one function and just delegate routing and processing to that?
Okay, so I guess there's two things there to that question. So again, so if I was supposed to put an API 100% in functions, like what would it look like, right? For you know, to kind of simplify it a little bit. So let's go over to, so if we look at the composition of a function app. So first thing I want you to see is like, my function app has multiple functions in it. Right? So that's one thing that you can notice. Now, the way that you organize your functions is very much dependent on how you organize your application, right? When people talk about microservices, right? Like how micro is your microservice? Like how do you want to break those things down? That's very much dependent on how you want to set that up, right? So I'll show you an example. So I could have a function app. My function app could just serve orders. I have another one that But maybe inside of each function app, I have multiple functions, right? Like get order for this user, get all orders, get orders by category, right? And again, those would be individual functions instead of a single function app. Or you could just have like a function app called store that has a lot of stuff in there, right? So again, like how you break that down, how you want to scale is very much dependent on you. Because remember, like when the load hits, it scales on the function app level, right? So like this thing here is what scales, right? So if you want to scale the entire thing, you probably don't want to do that, right? Like you probably want to break it apart and say, okay, well, I want this piece to get bigger. So if we kind of go back and think about the analogy of like a store, right? So if I have an online store, right? And let's say, again, like I have a lot of people coming in, I'm expecting my inventory is going to get hit a lot, and my payment processing is going to get hit a lot. Now, I don't want to create 5 copies of my website, right? I probably just want to be able to scale that particular part that I know is going to take a lot more load. So what if I said, okay, my store is made up of these sets of functions, and I know specifically, like when stuff happens, like I'm going to scale these specific parts. So I'll have an FLADotNet inventory, right? And I want that one part to scale. That'll scale until whatever, but then the rest of my app stays the same because I don't need that part to move around. Also, too, you want to think about it from a deployment perspective. You know, because each function app is a unit of deployment, right? So, like, you know, depending on how, if you break it up in terms of teams, if you break it up in terms of versions and things of that nature, like you want to think about like how do you want to separate this app or these collections of apps or these collections of functionality to kind of bring them together.
But what you have is, it looks like it might be possible to have all of that in a single, let's say in the case of .NET, inside a single .NET project, and then just use the attributes to decorate the class and then say, okay, here's a function, instance, function. Or would you only have one function attribute in a .NET project?
Sure. So per project, so a project relates to a function app, right? So again, so if we think about solutions in Visual Studio, right? There's a solution of solutions composed of one or more projects, right? So each Azure Function project will relate to one Azure Function app in the cloud. Right? So when I click right-click publish, it's going to take all the functions in that single project and it's going to put it inside of that app. Right? So again, like inside of Visual Studio, I pop back over here really quickly. So there's nothing stopping me from, in this single solution, adding 2 or 3 more function apps. Right? But they all can scale and get deployed very differently. So again, it's thinking about like however you think is best for your application to be split apart, that's essentially what would happen here. It's like the same thing, if that makes sense. Yeah, question?
What about having QA or different environments in the functions? Do you need to create duplicate functions, like one for QA and one for production?
No. So one of the things that we have, kind of, sort of, is sorry about that. One of the things that we have instead of functions is this thing called slots. So again, if you're familiar with app service, so app service, we can create slots, right? Slots are like in the same cloud resource. I can say this is my production slot, this is my QA slot, this is my staging. And what I can do is I can switch which one is active, right? So again, I have a function, right? My function has a URL, just like I had that HTTP trigger. And in the bottom, I can create these categories, you know, testing 1, QA, blah, 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 whatever. And now I can switch the active one. So if I say, okay, I want QA to be the one that answers the question, right? Like I can switch that. Right? Very similar to how app service kind of looks like. The thing is, it's in preview for a reason. It's not quite ready yet, but essentially, like that's the purpose that it will serve. Another thing that we tell people to do, or what we were doing until this is properly released, you can just create another function now. Because again, it costs you no money. You know what I mean? So you can create more apps and then just give them a different name, have a particular naming scheme. So instead of FLA, I could have FLA.net-dev. You know, because again, remember, like this is not costing you any money until it actually runs, right? And then when you're done, like through your, again, VSTS or Travis or whatever it is you use for CI/CD, you can just say, okay, well now I want you to switch and I want you to send it. But hopefully, whenever slots is ready, then that would be something that we can do. Yeah, question?
Are there going to be extra challenges if you need to save or retrieve data from on-prem, non-Microsoft databases, say Oracle?
No. So two things can happen, right? So today, like I was telling you before, like it's not a big deal if you want to bring in like an Oracle package and write ADO.net that targets Oracle. You could do that just fine today because again, it's just .NET code. Like there's nothing special you have to worry about. Yeah, there's nothing special you have to worry about. Again, probably your biggest concern would probably be making sure that you protect your connection string the right way. You probably just don't want to have it clear text inside of the code like that. You want to have like a, maybe use Azure Key Vault or some type of encryption to kind of hide that from you. And that's not very hard to do. But other than that, it's just code you can just do. Now, if you wanted to do something like the bindings, what I showed you. So again, the thing with the bindings is that I could, access queues and database and things of that nature without using the SDK. And it's just like, here's a string, we'll create it. Here's an object, we'll put it in the table. For that, you have to create your own binding. Because today we don't have Oracle bindings, or Oracle have to create a binding. People do that. We have bindings from Google and other places too. So if Oracle decides to create a binding, it's just be a matter of bringing it in, and then essentially all you do is, you put the attribute here, right? So instead of timer trigger or whatever, it's say Oracle binding. You know what I mean? And then you'll be able to work with it. So there are two options there. You can create the binding yourself. You can just bring in a NuGet package and just keep working. Anybody else? Yes, sir?
When you hooked an event in blob storage, for example, with an Azure function, or a CTP trigger.
Okay. Alright, so you can only have one trigger, right? So
per function.
Per function, right? So HTTP trigger and a blob storage trigger are two triggers. Those are two separate events happen. Right, like there's I made a request, get, put, post, delete, whatever, and there's I uploaded a blob, or deleted a blob, or renamed the blob, whatever the case is. Like stuff happened in my blob, and sending events. So what you probably want to do instead is determine, well, what is your unit of like activation, I guess you could call it, right? Like what's the thing that you want to have started? And if I actually go back, so what I'll do is I'll come over here really quickly, and I'll show you our recipes. Because we do have recipes for blob triggers. So if I come in here and I show you triggers and bindings, and I come down to... We used that on there for blob triggers. Did they go away? Oh, Q storage is almost the same like blob triggers. So let me show you. So essentially with this one, right? It's like, this is an example of a Q trigger. So what you want to do is you probably have a blob trigger instead, right? And now you just say, hey, I want you to listen to this particular container inside of my storage account. And then when stuff happens, then you can react to it. Anybody else before I go keep going? No? Alright. Alright, let's go. So what I was talking about before, so again, functions are really great at creating like individual units of functionality. Right? But now when it becomes time for you to kind of work with multiple functions that need to talk to each other, then that's a little bit more tricky to do. Right? Like if you think about creating a web API, like your web API probably has individual functions, and they're probably not talking to each other. Right? Like get user, delete user, update user, probably very independent. Right? And they have their own URLs, they have their own access points, right? And they operate, outside of the others. When it comes time to do things like coordinate functions together, I need functions to run in a particular order, or maybe I need to maintain some state, right? Because I want to run one function multiple times or something like that. Then we talk about orchestration, and that becomes something where durable functions kind of comes in to help with that. Right? So again, durable functions are extension to Azure Functions. It's just a NuGet package, it's free, nothing special needs to happen. But essentially it gives us a set of APIs and a service that allows you to define workflows in code, C#, JavaScript, languages that we support. But again, like it lets you kind of coordinate multiple functions together. And that's one of the really good things about it. And again, you do it in code, and then we also have the ability to do replays, which is kind of interesting. So replays, yeah.
So what's the difference with logic apps?
So logic apps is not code. Logic apps is an designer, right? So logic apps is like, again, for those of you that don't know logic apps, so I go into a website and I click. No, I'm not going to show you. I'm going to go to a website. I'm going to click, hey, start this, if then, else, and it's all like clicking buttons and adding boxes and moving them around as a visual designer, right? Now, with visual design, there's a limitation that you're going to hit when you need to use certain parts. You know what I mean? And so at that point, when you need more control, and then two, when you want to write code, then you're going to want to dig into durable functions. But if you're totally fine with like a designer and dragging boxes and stuff around, and that suits your need, you have the connectors that you want to work with, so that's totally fine. Right? So again, it's when we pass the limitations of what can happen in a UI, when we want more detailed, exception handling, and being able to use Visual Studio and debug our workflows, being able to do some of those types of things, and that's when you want to come into durable functions. Right? So again, like it's still Azure Functions, and we're still writing the same functions that we saw before. We're just kind of running through it in a little bit of a different way. So there's three things to know about durable functions, right? Like there's three components that kind of make them work together. So first is the orchestrator function, right? So this is the function, and again, it looks very similar to a regular Azure function. This is the function that kind of defines how things work, right? Like what order my functions are going to run in, my exception handling, my logging, like a lot of that main workflow is kind of defined. So when you look at it, you see I have things like check and reserve inventory, and process payment, and schedule shipping, and email customer. One of the things you see is that this is a very short function, and it's not actually doing any work. It's telling other people to do work, and it's telling them the order in which to do that work, right? It's the orchestrator, right? Like it's like your director of your movie, right? Like this is how things are going to go. And then after that, we have the activity function. So this is where actually work happens. This is where if I need to do anything with async, like I'll do it inside of here. If I need to do anything with IO, I'll do it inside of here. Like long running tasks, like I'll do it inside of here. Like it happens inside of the activity function. So again, the orchestrator just says, hey, this is the order I want things to run. And then the activity function is actually, this is what I want to do. Right? Does that make sense? Kind of, sort of, maybe? Not sure. Question? What creates the context? So Azure Functions creates it for you. You don't have to create it.
So if I
Okay, so then your question then, I want to change your question. Your question is, how do I start this? Right? How do I start this function? So I showed you the orchestrated activity. So this is how you start the function. Now, durable function itself lives inside of Azure, right? It keeps a workflow. So if you want to trigger it, you trigger it with some existing trigger. Right? So if I want to trigger it with like HTTP, queues, timers, blah, 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 whatever the case is. So I'll write a regular Azure function. This is like the same functions we've been seeing the whole time, nothing different about it. With the exception of, I have this thing called an orchestration client. Right? So the orchestration client is what I'm going to use to, I can start a workflow, I can stop a workflow, I can terminate it, I can check the status of it. Like it lets me interact with it while it's running. Right? Because again, like your orchestration is probably going to be multiple steps. It's probably not going to be done in 10 seconds. It's probably, we have orchestrations that can probably run for days or weeks or even months, right? So this is how you do it, right? So I have my orchestration function, and essentially I just call start new and the name of the orchestrator. And then when I start my orchestrator, notice I'm getting back this thing called instance ID. So the instance ID is that instance of that workflow that's running, right? So it's kind of like, again, I just created a class, and here's the instance of my class, and here's the instance of this orchestrator. And so now that instance ID is probably something you want to hold on to, because you want to come back, come back and check it again to see, hey, is it done, is it running, is it, like what exactly is happening with this right here. Now, before we go on to the demo, I want to talk about checkpoint and replays, because this is the thing that really makes Azure Functions special. Now, with functions today, so your functions have a limit of 5 minutes before they stop running for a regular Azure function. So there's a limitation on it. You can't just run functions until whenever, right? Like it has to stop at some point. Either you stop it or we're going to stop it. Right? Now, what happens if you have a workflow, if you have something that you want to do that's going to take more than 5 minutes? Right? So one of the things that we do is we enable checkpointing and replaying by maintaining queues and tables in the background for you to make sure that we're keeping that state. Right? So, hey, what function is going to run next? And then we create a queue, we drop the queue message, and then the runtime is going to run that particular function. Or, remember when I showed you we had those different activity functions? Right? When I'm running my Azure function, when I hit the first, actually, let me go back. When I hit the first activity, so like, you see I said await context call activity async. When I hit that activity async, essentially what happens is that this function goes to sleep. It's not running anymore. Like remember when I told you in the beginning that you pay per use, right? But if you have a function that runs for months, I probably don't want to be paying for it for months, right? Like I only want to pay for it while it's running. So what happens is that this function goes to use and it checkpoints itself. It says, I'm going to stop here until whatever activity that is finished running, right? Because imagine if we didn't do that, we'd essentially be getting double billed, right? Like, I'm waiting over here, and then something's happening over here, and that's a function, like we're paying the function twice. That's a little crazy. So, every time you see await call activity async, essentially what happens is it goes to sleep, and in the background, we have some tables that we manage for you that keeps your state. So the Azure function runtime knows what functions you're on, how far along in your workflow you got, and then where to continue, right? And if you had errors or anything like that, like you could go and say, okay, well this is the part that I had an error, I can rewind and I can try it again, right? Like you can do things like that. So this is what makes durable functions different from Azure function, is that we're maintaining that state for you. Like we're doing the replays, and we're keeping that information again managed in the back. And we do them using like a thing called event sources. If you ever heard about event sources. Yes, sir? So what happens when you do that? Okay. So yeah, you see the question. So his question was, what happens if he updates the function while another one is still running? So so we usually recommend that you don't do that. That's not a good idea. So one of the things that we recommend people do, so obviously it's usually good to have like a versioning strategy. Versioning strategy is in like, hey, I'm going to maybe like deploy to like the slots like I was talking about, or another function app, and then eventually move things over. Another thing that we tell a lot of people to do is just make sure that your things are done, not running. But again, that's not available for everybody, right? Like everybody can't do that. So essentially what will happen is that while it's running, like it's going to finish, and then for that particular instance, what will happen is that it'll just swap over. You know what I mean? But now you have to think about like, again, like if you're talking about an API, you have to think about what does that mean for your clients, right? Like if you're building a web API, right? And a web API that's backed by durable functions, what happens is like you change the version and the payload changes, or the semantics of the URL changes, right? Like so again, like we have to think about some of these things. Like we could swap it for you, but like, is that really what you want us to do? Or is that really what you want to do? You know what I mean? Okay. So let's go forward a little bit. Alright, so that's checkpointing and replay. So let me show you really quickly just my very bad PowerPoint skills of how this works. So we have our orchestrator function that's going to run, right? And then what you're seeing on the right side, that's the table, right? If you can see that. So my table is saying the orchestration is started, right? So it's essentially like starting to put messages in there. Now, when it hits the first call activity async, I'm going to call some function that's going to be called say hello. So now notice my orchestrator function is going to put something in the history table. Then it's actually going to call the activity function. And notice as it's doing it, it's adding those events to the table. My activity function is going to run, it's going to return results. Again, all that's going into the activity table, the history table. When that function is finished, my orchestrator wakes up. So remember, we went to sleep before, now it's woken up. And what it's doing is that it's going through the history. Like, where did we stop at the last time? Right? Okay, we stopped here. going to replay itself. And it's like, okay, I ran that function already. I'm not going to run it again. I'm just going to return the result. Right? So obviously, like the more call activity asyncs you have in there, like the more time it will go. Essentially, what it does, it goes to sleep while the activity function is running, and then when it's done, it wakes up and says, okay, well, where can I continue running? And again, that's all because of the queues and the tables that are in the back. That's maintaining that state for you. All right, so let's take a look really quickly at. Let's look at some code. So I created some samples for you all. Let's look at this one. So this one's called log running APIs. Now let me show you the activity functions first because they have the least amount of code in there. So remember, my activity functions are the things that do work, right? So please don't be surprised that there's no work in here. But essentially, what I do is I have a setting that'll simulate time, right? So all this is doing is that this is just going to wait for some period of time. This is like me simulating actual work happening. Obviously, you'd have like your real code in here, but for the sake of the demo, like I'm just simulating like a wait, right? So I'm waiting for this thing to be done, right? And this is essentially how most of these are written, right? So you know, process payment looks the same. If I look inside of here, all of these are like just activity functions that I'm simulating work happening by that's pretty much just pausing the function. Now, let's look and see how we can actually start this. So, kind of like what your question was. So I have an HTTP trigger, right? An orchestration client, and then I'm just keeping this instance of the orchestration that runs. And then if I look inside of my orchestrator, again, all that's happening here, there's a lot of code here, but this is essentially just saying, call 1 operation, 2 operation, 3 operation. What I'm doing is that I'm doing some logging, and then I'm also setting the status of the running contents. But essentially, all that's happening here is that I'm just calling 3 different activity functions. That's what's happening. Any questions about the code before I run it? Yeah?
So, orchestration bot, let's say my inventory call fails. Where do I put that
If one of the calls fails? If the activity fails, or the orchestration fails?
Within the orchestration, if one of the steps fails, is there anything in the verbal function that allows you to put that logic in place?
Sure. So remember, verbal functions, at least from what I'm showing you here, it's just C#. So it's just a try catch. That's it. You know what I mean? You might want to have a strategy of, so some people, for instance, they put their try catches in the activity functions, depending on what it is. Or some people just let it bubble up. If you let it bubble up, you can have a global handler if you want. Again, depending on what your workflow is doing. You can have a global handler. I can wrap this entire thing in a try catch. And now I can just send my logs to application insights or my alerting system or to my telemetry collector or whatever. But again, this is just C#, right? So again, simple try catch is really all you need.
Is the other individual, sorry to continue with this, is the other individual calls going to bubble up to this call? Or they have to, and if they fail and log themselves, right? Or
so they don't have to. They could log themselves if they want to.
Yeah.
And they could. So if I went back down and I was supposed to look at the activity functions, like the functions that actually do work, right? So I can put a try catch in here, right? And I can return like an erroneous result or return null or something like that. And I can throw an exception. And I can throw. If I throw now, it throws up to the calling orchestrator. Okay. And then the orchestrator would have to deal with that instead. Right, so again, very much, it's just C#. So very much the same way when you think about handling exceptions, it's very much the same like this. I can handle it on a more detailed level, or I can just have more like a global catch-all, so to speak. And I can put it there, if that's what makes sense for your application. Alright, so I'm going to go ahead and run this really quick so we can see some of how this replay runs. So I'm going to set this, so again, I'm going to run this, and now I'm going to use Postman. If you guys are familiar with Postman, it's just a simple HTTP tool that you can use to create requests and things of that nature. So this is running. Now, when this is ready to run, what you'll see here is, notice it shows me all of my HTTP functions and tells me the URLs that they're running at locally, so I know like what's the endpoint that I can use to hit these. Now, over in Postman, I created like a collection. And my collection is pretty much essentially me like saving the request so we can see what's going on. So I have this one called process order, right? So process order is going to call, let's move some of these things around a little bit. So process order is going to call this orchestrator, right, that I have here. So I'm going to go ahead and run it. What you should see is that this should come back pretty quickly. I'm going to let that run. So this should come back pretty quickly. But while my orchestration is running, what I have here is a payload that's kind of giving me, what I have here is a payload that returns to me automatically, and it's giving me endpoints that I can use to query my running orchestration. Right? So here, I need to make this run faster. So here, what you're seeing is that I have one, for me, I can query the status, I can send events, and I can stop the running orchestration. Right? So let's click on one of these and see what happens. If I run this, so notice when I run this, I'm trying to query now. I want to know what's happening. Is my code still running? Right? It's letting me know that, hey, this is the instance of my running workflow, and it's still running. It's not done yet. Right? And I just kicked it off. So something's in the background that's running. But notice it also gives me some information here. Like it tells me, you know, the inputs that I gave it. Right? So I created an order, and so it's processing that order. Here's the ID of the order. The creation time, the last updated time. And so what we can essentially do is we can just keep clicking this. You know, at some point it will be done. Like notice now this changed from changed to the order shipping schedule, right? Because now I'm changing the status, right? It's going forward, it's doing different things inside of the thing. So notice it changed now, customer notified, right? Like it's moved forward to the next step. And then notice now the runtime status is completed. So my orchestration is finished now. Now, one of the patterns that this kind of enables is if you have anything where you want to monitor stuff happening. So let's say I have a web UI and I just kicked off a bunch of stuff running. I could create, you know, Angular app, ASP.NET app, some web front end or mobile app, right? And I kick off a bunch of orchestrations. I could just have it polling every now and again to check and see what's the status of this thing running. Right? So if we go back to the use case of like an order processing situation. Right, like you ever go into Amazon when it's working, and then you see at the bottom it says, okay, well, order placed, you know, order shipped, delivered, and like you know, there's a little workflow inside of it. You can essentially create something like that by simply just polling this endpoint to see, well, where are things now? Now, one of the things that we added are really cool is this custom status thing, which actually sounds pretty trivial when you think about it, but essentially you can give yourself like some metadata to know, like, what can I report on what's happening inside of that running orchestration? Right? Like you might want to know something more than it started, or you might want to know, okay, it started and this is the shipping number, or you know, it's running and this is the email address that I use for this user, right? Like you might want to get some more contextual information, and so we could set the custom status to get some of that, and you can get it inside here. And essentially, all it is really is a call to set custom status. But again, when you see it, you know, actually, you know what, I'll give you an example too. So when I used to work at Mobile, I had a project I was working on, and I had to write an application for managing dissertations for PhD students. So the way that process kind of works is that you, as a PhD student, you go to your advisor, you propose topic, abstract, whatever the case is. But then as you go down, you have different levels of approvals. Like different people have to approve. Yes, you can go for, yes, I'll accept this. Like, yes, this is okay. So this would, you know, if this was like a couple years old, like this would be a perfect scenario for that. Right? Like if I wanted to manage like that dissertation workflow, like this would be perfect to do. Now, speaking about that specifically, I'm going to switch over to this other example. Now, the thing with dissertation, at least the dissertation that I was working on, was it was very much of a disconnected experience, right? Like, so the professor had to go in and they had to read the documents or proof the research, whatever the case is, and then they had to come back and log into a website and like click that approve button. You know what I mean? Even though they were doing stuff from outside. So, what if I wanted to create an orchestration that was dependent on things that I couldn't code for, or couldn't write code, like could write software. Right? So let's say, I don't know, like I wanted to do something like, you know, I sent you an approval code on your cell phone. You know what I mean? I want you to click this thing and then it's automatically going to send, you know, an approval status. It's going to let my workflow go forward. Right? Like if I had some type of thing external external from my system that I wanted to say, this is a part of my workflow, but it's not something I can control. But I'm going to give you the ability to listen and signal for that and go forward. Does that make sense? It's like a little weird when you think about it until you actually use it. But the way that actually happens, so instead of me calling call activity async, I have this thing called wait for external event. Right? So I can define what my event looks like. I can define what my event looks like, and then I can wait and listen for it. So again, like I sent you an email and I want you to confirm your account. Like we all get those all the time, right? Like click on this link, confirm your account, right? Essentially what I can do is I can have this workflow wait, and when I click on it, it'll say, okay, that event was received. Now I can kind of continue running. So let me run this again really quickly. This will probably be the last one where I show, and then you can kind of see how some of this works. So this is going to boot up just like it did before, and now I have a start dissertation thing. So again, essentially all this is going to do is this is just going to say, hey, I want you to run this dissertation workflow. And let me go back here. I want to make sure I put some breakpoints for this so you see that work. So I'm going to go ahead and start my dissertation workflow. I'm going to kick this off. So notice now the breakpoint is at this first one, right? So I'm going to go ahead and let this run. Now, if I do absolutely nothing, then nothing's happening here. This is just sitting, it's just waiting. I'm not running an activity function. I'm not getting charged. My function is just waiting. It's waiting for you to tell me, yes, you could go ahead and you can continue doing your work, or you could move forward to the next step of whatever's happening, right? But again, like, nothing's happening. Like, it's dead. Maybe that's not a good word, but it's not moving. So what I can do, so again, I have this other thing that I could use to send things over. So I have this event that I personally defined. This is not a part of the framework. I gave it an event name and a status, right? And I know that my function that's here is waiting for abstract approval, right? So I'm going to say abstract approval is approved. Me as a professor, I approve your abstract, go forward and start working on your dissertation. So I'm going to go ahead and send this. Boom, right? So now my function wakes up. It's like, oh, I got the thing. And I can continue working, right? And it's going to be the same for all of these. I'm not going to run all of these, but essentially you get the point, right? Like I'm going to go ahead and click run. Now it's going to go back to sleep. It's going to wait for this one. And then I'm going to say, okay, well, this stage of my dissertation process is approved. I'm going to send that event, and now it's woken up again, right? So again, if I had things external from my system, things that I don't control with code, at least in terms of actual activity running, I can very easily just send events to my function to be like, okay, well, I'm just going to have you pause and wait, and then whenever you're ready, you can continue doing what you're doing. Any questions about that part?
Hold on.
Yes. Sure.
I maybe missed that, but while you are waiting for external events, you're not paying for anything, right?
Nothing's happening. You're not paying, no code is running like this. It's sleeping. Yes, sir.
When it resumes, though, is that a new function call, if you will? It's another execution.
Yeah, so when it resumes, it's a new function execution. So essentially, so remember I'm talking about the replay? So now it's going to replay, it's going to look at that event source data, that's inside of the table. It's going to replay until it gets to that point. But it's not going to run the events, right? It's going to say, okay, I did this part already. I can skip it and I can go to the next one, right? And so when it gets to something that it hasn't run before, then it's going to add something else to the queue, it'll checkpoint it, and then it'll wait for that to be done. Question?
So the state of the event, when it's waiting for another event to kick off, that's all being stored inside Azure SQL, or?
No, so that's stored inside of Azure Storage. So because I'm running on my machine, I have my local storage emulator running.
Yeah.
I'll zoom into this so you can see. So this is my local storage account. And so one of the things you'll see, so notice I have multiple queues. I didn't create these, right? Like the front end just creates and manages these queues for you. So again, as it's talking to like different parts of itself, like it manages these queues.
Yep.
But on top of that too, there's also something called the history table, which is this thing right here. So if I look inside of my history table, and I'll move this around a little bit, My history table will tell you, so you can see those events in order. And if you want, you could query that yourself. I mean, it's not a hidden table, right? So you can look and see like what order they ran in. You can see the IDs for everything. If I scroll over a little bit, like if any of these things had results, like so this one had a results or input, you know what I mean? I could kind of scroll across and I could see like, right, so none of these have results, but right, so some of these have results, some of these returned null. So I could kind of come in and see what actually happened. So from a debugging perspective, right, like if there are exceptions and things of that nature, you could go in there and see that.
Then the next question is, so how does Azure charge you when you're using something like this? Because what if we have, you know, a lot of what if we have high throughput, high volume, and we're at, you know, 1 million of these various different states, right, waiting for events to come in? How does the charge work in that scenario?
Sure. So for Azure Functions, period, like you're required to have a storage account. So that's one thing. Storage is pretty cheap. Like Azure storage itself is ridiculously cheap. Like you can get a terabyte for almost nothing. You know what I mean? And then these events are very small. Like this is not binary data. This is not pictures and video. We're talking about like very, you know, minute slivers of text, right? So, from that perspective, like that's not expensive. From the running perspective, again, remember, like you have your free executions in running, and every time I hit a checkpoint, like my function goes to sleep. So I'm also not being charged for it there, right? So storage is cheap. I sometimes get charged for the execution, or sometimes it's just waiting for stuff to happen. And again, I can wait forever. Like I could just sit and wait for stuff to happen. But while it's waiting, like nothing happens. I'm not being charged. I'm not getting a bill or anything like that. Like it's just waiting. So those are the parts where you get charged. Yeah.
While we're on the topic of billing, I just had a question. So in the case of an HTTP function, you decorate and tell it this is for responding to a post versus a get versus a put, right? And yet the endpoint is going to be shared within that, you know, function app, right? So if it's a post and matches the function, that's obviously a build execution. What if it's a get and you don't have a function for a get? Will you actually get billed for a get?
No, you get a 4.0, is it 4.5 or 4.9? Essentially just a method not available.
But it's not considered a billable execution.
No, because it won't match the routes. So if I show you my HTTP function, I have one somewhere here. So right, so you see here in my function here, like I have a route, right? And my route not only specifies the URL, but it specifies the methods that I accept. So if you try and send you know, a delete or heads or options, and I don't support it, like it'll just come back to you. Like this function will never get run.
So I'm assuming it's similar on a blob. Like if I only want to respond to a delete event on the blob or you know a new file that's being placed into the blob storage, I won't be billed for other types of events.
No.
Got it. Perfect. Thanks.
Yes, sir.
So to have the activity tracking, is that done by using the activity functions as a marker? Say over here, I'm going to, in other words, if
when does checkpointing happen? Is that kind
there's
of
a statement at the bottom of a method get checkpoint, or is it only the calls to activity functions?
only the calls to activity functions. So only when I call, so only inside of my orchestrator function, when I call wait for external event, or if I call activity async, the results of that operation is what is going to get checkpointed. So if I had an if statement, like my if statement doesn't get checkpointed, or if I had like some other things in there, that doesn't get checkpointed. One thing to note about these functions, so notice when I call it, like I'm not actually calling the function, I'm passing it a string with the name of the function, and it runs that. Now, there's two reasons, well, there's a couple reasons for that. But one, Azure Functions, again, is built to scale. So one of the things is that when you run your durable function, when it calls your activity, it might not necessarily run on the same machine or in the same process, right? Like it's going to kind of spread itself and like, shoot, whatever machine is available, I'm going to run there, right? Or whatever machine has resources, I'm going to run there. So So again, as you're designing and you're building these things, you gotta kind of have that in mind, right? Like you can't try and read to the same. You probably shouldn't be reading the file system anyway, but don't try and hit the same drive or local space because it's not going to be on the same machine. Most of the time, it's not going to be on the same machine. So when you think about the checkpointing again, that's why having like these tables and queues helps so much, right? Because it's one collection of tables and queues. Well, wherever my function is running, I can come back and talk to that source of truth, right? Like my event source of data is my source of truth. Like where are we right now? What are we doing? What's next to happen in the pipeline? And then again, wherever I am, I can kind of just come back home and see what's happening. Yeah.
Does the runtime then take care of doing the version, the serialization and the serialization versioning between, let's say you deploy a change to a durable function, the definition of a durable function. I assume that there's some sort of correlation ID that says, okay, for this message or request or context, I'm going to keep using deserializing to this type, to this version of the type. But then the new one you may have added a column or something like that. Would you have to take care of that sort of versioning concern, or would the runtime take care of that?
I mean, you should.
And if you take care of it, do you then have to, start using gRPC or something like that?
Sure. You should think about it from the perspective of if you deploy something and you know that it's different. Like obviously, you should know how that affects your clients and the things that are interacting with that thing. But again, for us, like as soon as it's done, like we'll just swap it over. Because when you think about it, like we're talking about, the DLL is compiled and it's existing in memory in the runtime, right? So usually what happens, again, we're talking about ASP.NET, you drop a new DLL, like it restarts the whole process. You know what I mean? Because we're scaling across so many different machines, essentially we're just going to swap it back into memory, right? Like whenever this thing loads, we're going to swap it back into memory whenever your thing is done. But then you should know how that affects your clients, right? Like if your clients automatically see a new version, they'll be like, whoa, I don't know what this is. Like, how do I deal with that?
But if the checkpoint is automatic, do you control the deserialization process there?
No.
So then there would be no way to, I don't know, like, it seems like you would not really be able to make sure that that you have a way to manage versioning when you're doing the event source.
So when I say done, right, like when your orchestration is done, it'll swap it over. So when it's done, like your checkpoint doesn't matter because you're done. You know what I mean? And that data is still there. You can still look at it, right? You couldn't restart it. For instance, you can't restart that orchestration because your thing is different. You know what I mean? But I mean, it's done. So you can keep that data. You can continue to ask for, hey, what was the result of that particular instance? As long as you keep the data. You know what I mean? But other than that, it'll just stop.
So as a run-on to what he's saying, so for versioning, if, for example, you were to push a new version of this, as long as you had to wait for external events with those expected events, since it's going to rerun the function and target that wait for external event call, is it going to then pick up the data for, say, stage 2 approval, and then whatever code you're going to have after that wait is going to, execute? You follow what I'm saying? So like, you already have data in there, it's in the queue, you went, you pushed a new version, the new DLL and everything loaded up, but you still have an appropriate wait for external event call, right? And it's now going for stage 2 approval. And so it raises that event, does it hook back into wherever that line is now in this function, in this code, as long as you're waiting for that particular event? Of course, if you changed it, it wouldn't have an appropriate event listener. But I'm guessing that it would respond to stage 2 approval, and whatever logic you have for that, of course, would execute.
Yeah. So I think there's So a couple things can happen. If your payload is different, right? Like, so I have a payload that has a status and an event name. If my payload happens to change, and let's say I added or removed fields or renamed, like versioning on the payload is different. So when it reloads, like it's not going to accumulate into that anymore because it's different. It looks like something else. You know what I mean? So in that case, two things you could do. You could, like in your new version, right? Like you could look for a different thing. You know what I mean? And then we could do those things like with playing with like async awaits and try with any type scenario and play around that a little bit.
Let's say it didn't change. All that changed was what you're doing with the payload, right? Mm-hmm. Then it would just wire back into that appropriate wait for external event, right? Yeah. Okay. So on that score, I had a question earlier that I was holding on. What sandbox, so to speak, are you put into to shield yourself from other customers gaining access to your code? Obviously you shouldn't be storing things on the C drive, but if you could access the C drive and another customer could presumably access that and go search through the cache for your DLL, what does Microsoft do to sandbox one customer from another?
Sure. So two things. So depending on how you deploy your function, so you can deploy your function as Docker containers. That's an option. Your container is your container and doesn't belong to anybody. But also too, we deploy to a VM. Like it's your VM. Like you're not sharing. At least with functions, you're not sharing.
And that is the scale.
So that's one of the reasons why when people talk about, like, you ever hear anybody talk about cold start? Like, so one of the problems or one of the things that causes cold start is the fact that starting up the environment is expensive, right? Like, you already have the code, you already have the app, right? Starting the environment is expensive. So if I have to provision a new VM, and you're coming at me with like 1 million requests a second, like, it's a lot of VMs. Like, you're gonna have to take time to spin up the VM, you gotta plug it into the network, you gotta deploy the code, you gotta warm it up, like that takes time, right? But you have the comfort in knowing that, hey, I didn't just copy your code and put it next to this guy's code. Sorry, I didn't mean public. I didn't just copy your code and put it next to somebody else's, right? Like you have an instance that's essentially yours. So you don't have to worry about it.
So then in a continuous service plan, or whatever, what was it called?
Consumption plan?
Consumption plan. How does Microsoft then scale this? Let's say that you are, running something through Super Bowl, and you're expecting all of a sudden to have this huge increase, but it's not per your baseline.
Sure. So we have pools of servers that are just waiting. I couldn't tell you what the number is, but they're VMs that are just in a pool, just waiting for work to do. And then what will happen is that as obviously more people start to hit, there's an exponential increase of those VMs. So that's essentially what happens. That's what happens now. On all of them, yeah, sure. So the pool makes it faster, but you still have to wait for it to get there. You know what I mean? One of the things that, again, so if you use C# and you use compiled functions, so you didn't write it in the browser, you compile to DLL and publish with Visual Studio. So one, you don't have to have that recompile happen. If I wrote it in the browser, you notice there's that CSX file, not a .cs file. The CSX file is compiled, not interpreted, but like it's going to be compiled at that point. You know what I mean? So that's one thing you don't have to wait for. Two, we have the pool, so that's another thing you don't have to wait for. So now all you need to worry about is how long is it going to take for me to copy paste into this VM and plug it in. You know what I mean? So again, it's still not instantaneous. You know what I mean? Even if we're running containers, it's never going to be instantaneous. It can seem that way, but in the back end, like there's always going to be like something has to happen to provision that works right. Yeah.
So containers is like my topic, but it's to help out. So Service Fabric is one of the key engines that they use, right, for running this. My question is though to you, Cecil, is what's do they use .NET Core for Azure Functions, or is it just standard .NET 4.7 or 8.
Sure. So there's two versions of functions now. There's functions v1 and functions v2. Functions v2 is in preview. It's not, as in like you can't call, let's say you have a problem kind of thing. Functions v2 is .NET standard. So you can run .NET Core or any .NET standard 2.0 compliance library, right? So functions 2 is .NET standard compliant. Functions 1 is .NET 4.7.2? 4.7 something? So it's running full framework. Anybody else? Yeah.
To that end, so two questions. If I'm going to run, so was .NET Core one of the languages that had needed the experimental flag?
No, so .NET Core is not experimental.
Remember that there were some languages you showed us.
Yeah.
That's okay. That's good. You can answer. And if it's, what's the difference? If I'm a node guy, so if my JavaScript is running there, it's running on.
Sure. So there's a couple of things that kind of enables, right? So one, like our infrastructure, like can run on different things now, right? Like, so I can have functions deployed to Linux, Mac, whatever, right? Like it doesn't matter. It shouldn't matter, but we have some customers that are very like, they have an affinity to a particular development style, right? So if I develop on a Linux machine, I want to publish to a Linux machine. If I develop on a Windows machine, I want to publish to a Windows machine. So that's one of the things that enables. Another thing that we're doing that it kind of enables too is our out-of-process model. So because .NET Core is so small, it's a lot easier for me to copy it, move it around, and like deploy it somewhere, right? Like the acquisition or the publishing process is a lot faster and it's a lot simpler. So when it comes to our out-of-process model, so our out-of-process model pretty much is like, here's the function runtime, and then here are language servers. Right, so Node's here, Java's here, this is here, that's here, and then the function runtime can communicate to that language server, essentially. Right? Now, with .NET, because functions is written on .NET, it just made sense to run it in process. When we run it in process, what happens is that we end up with NuGet package conflicts, binding redirect issues and things of that nature. So again, us moving it out of process, like that's another benefit, right? So again, we have the benefit of different machines, we have the benefit of that faster, smaller deployment unit, and then we also have the benefit of better being able to handle those those binding redirect conflicts. Anybody else? No? Alright, cool. So let's spin forward a little bit. So I want to talk about, last thing I want to talk about is what are some of the limitations of the orchestrator. Right, so we talked about all the cool stuff that you can do. Let's talk about the things that you should not do with it. Because of the fact that we're doing event sourcing, we're doing replay of those events that are stored inside of the table, the code inside of your orchestrator has to be deterministic. Which means that like if you run it 4, 5, 6 times with the same input, it needs to give you the same results. So if I have things that are generating GUIDs and random numbers and calling datetime.now, that is not deterministic. Datetime.now is different every time you run it. And then creating new GUIDs are different every time you run it. Right? So the function needs to be deterministic. It needs to know that, again, when I replay these events, I get the same output, or I get the same state. Right? So one of the ways that we can work through that is that we do have, off of the context object, the orchestrator context object, we have different operations like, again, gets, UTC, dates, for functions, for numbers and things of that nature. So for those types of calls, like we have, I guess you can call them polyfills or whatever you want to call them, but we do have operations that can deal with that. But just don't do that yourself, because again, it's going to make your debugging and things of that nature a little bit harder. The orchestrator itself, so again, the orchestrator, not the activity function. The orchestrator is single-threaded, right? It's single-threaded for a reason, but your activity functions is where the work happens, right? So your activity functions is where the work happens. Your I/O, your data access, your web service calls, all that stuff happens in the activities, right? So then don't put it inside of the, don't put it inside of the orchestrator, because again, it's going to block your function, and then you're going to get very bad performance, and it's just not good for you. And that's very similar to the next one, right? Like, don't kick off any road thread, no task.run or thread.sleep or anything like that. Another thing too, so inside of your orchestrator, like you shouldn't have long running loops or essentially infinite loops. Because Because you imagine every time the orchestrator goes around, like you're adding to the history table. And every time you add to the history table, like that's another iteration of replay, right? So let's say, I don't know, like if you have 100 iterations, okay, well like what happens when I get to 1,000 or 3,000 iterations? That means that I have to replay this thing 1,000 times or 10,000 times, whatever the case is. So now your time to rehydration is going to just continue to increase, right? So what we can do is that we have this function called continue as new. Essentially, it's like purge, right? It's like I'm going to take your current state of FLADotNet, and then this is what it is today, and now I'm going to continue to append after the fact, right? So again, you're not continuously appending to this, this event source table, right? Like we say, okay, well this is where we are now, and now we're going to kind of keep going further from there. Right, so these are the things that you should not do in the orchestrator function. Again, not the activity function, but the orchestrator function. Now, I want to share these links with you. So everything I talked about, videos, links to the book, links to function recipes, all that is right here. This is a link of links. Like this link will take you to more links because I hate having like tons of links in a slide. It's annoying. So you can kind of take this picture, you can kind of go there, and this is really just a gist on GitHub that has a lot of different links. So one of the things we do is that we just continue to update this every now and again. So you might come back, look at it next week, and there's stuff in there that wasn't there before. So definitely come in here and check it out. If you have any other questions, again, I live in Florida, I'm here often, so definitely feel free to reach out to me on Twitter or David and Dave know how to get hold of me, so I'm always around. But if no other questions are there, thank you all so much. Appreciate you for coming. And good luck.
Right, guys, thank you very much, Cecil. And next month, not to forget about, do we have any more questions? All right. Next month, I think, what's the saying in Australia? Joe's going to have another suck of the, well, he's going again to explain about blockchain. Next month?
Okay.
No, I don't know.
Oh, okay.
No, actually, next week we're having an IoT cafe. So John Wayne from campus is going to come and talk about IoT and Azure, event room and IoT devices.
It's not.
Next week.
This Tuesday, next year, exactly 7 days.
We do not have
Unless you're from Colombia, then it's 8 days.
Yeah, we don't have the August meeting scheduled.
So it's South American thing. We don't have a schedule.
That's September.
Yes, so next month, so check out meetup.com/FLADotNet or FLADotNet.com, just to make it confusing.
Thanks for coming and thanks to Centric for sponsoring.
Thank you very much. See you next one. See you next week, guys.
This guy, or you tell me when? Right now. What are we doing? I don't know. Oh, you can't give me that. You gotta give me something. I know. Quick question. Thank you very much. Running around with a microphone? I'll be right there. Give me 1 second. Just press stop.